Okay, I am going to be recording how to do Module 1, Lesson 1, Independent Practice. And I'm going to be doing it on a separate piece of paper that can then be photographed and uploaded into Canvas. And so I'm going to do it as if that's how I was going to submit my work. Of course, you can also do it portrait. For the purposes of this screen right now, the camera records going this direction, so that's how I'm going to organize my paper so you can see everything. So, name, Ms. V or Ms. Van Loan, and what is this assignment? It is Module 1, Lesson 1, Independent Practice, okay? So M1L1 IP is fine. I can figure that out. And let's see, what else do we need? Technically, we should also have Math 7 Summer 2019 and today's date, whatever that would be for you. But that's getting really specific, and honestly, I'm just going to accept your work, but please include your name. Okay, and this is the main stuff you need, these two things. Okay, number 1. You do not have to write down the entire question, but you do need to summarize the question. So if you pull this up online, it says, what is the additive inverse of 8? So to write down the question, I'm just going to put additive inverse of 8 and a question mark. That's the question. Now I'm going to answer it by proving it using a number line. 8 is positive. The additive inverse is going to be -8. So my answer is -8. It helps to put it in a box so I can distinguish from your other work. Number 2. I'm going to scroll on my paper on my computer. It says evaluate, -9 plus 9. So I don't need to write the word evaluate here. I can just put -9 plus 9. I need to prove what that equals. I need to prove also what it is saying. It is saying that we are starting at -9 and we are going to add 9. So here is -9. If we add 9 to it, 1, 2, 3, 4, 5, 6, 7, 8, 9, we wind up at 0. So it equals 0. This is how to prove it using a number line. The reason I'm using a number line is because Module 1, Lesson 1 dealt specifically with number lines. Number 3, the additive inverse of -2. I'm just going to simplify it to add inv of -2. Now I'm going to prove my answer. So the opposite of -2 is +2. So my answer is +2. Number 4. This says evaluate -66 plus 66. -66 plus 66. It's going to work the exact same way as number 2, except I'm not going to draw out 66 little dots or lines there. I'm just going to show it in a general sense. This is -66. This is where we're starting. We start at -66. We're going to add 66 to it. So plus 66. This shows that I'm starting at -66 and I'm moving this direction 66 spaces. I wind up at 0. That's my answer. Number 5. What is the additive inverse of 8,964? So again, add inv just to simplify it. 8964, 8,964. Put my 0, 8,964 is positive. The opposite will be negative 8,964. So negative 8,964. Okay, number 6 says solve for x. And I'm writing the whole thing for a reason. Negative 771, negative 771 plus x equals 0. I noticed some of you guys are solving this for x the way that you would learn in semester 2 of Math 7. This is semester 1, so we're supposed to still be using a number line to reason it out, to use our logic of what we know about numbers to say we're starting at negative 771 and we're going to add something to it to wind up at 0. So what is that something? Well, using our logic of how we solved this one, number 4, we know that it has to be a positive. We're going to add 771. So x will equal 771. However, I'm going to also show you the method that you would have used in semester 2. We have, I'm going to put this, look over here, semester, okay, negative 771 plus x equals 0. What we want to do is isolate x. We want to get x by itself, which means we need to get rid of 771 negative. To do that, to get rid of it, we're going to add in the opposite amount. I'm going to separate my two sides. Remember, this is like a balance, two sides of a balance. And I have to add in 771. And then when I add all of this side, I have negative 771 and x and positive 771. These cancel out and make a 0 pair, and I'm just left with x. But now this side of the equation is very heavy and off balance because I added 771. So I have to add the same amount to this side in order to keep it balanced. And 0 plus 771 is positive 771. This method is a way of proving, a way of solving for the answer. It's really just an algorithm. The logic is right here, but this is a step-by-step process for how to find x when you get to more complicated situations. Okay, so this is not wrong, it's just semester 2, but this class this summer is supposed to replace semester 1. Okay, let's go back to our next problem, number 7. It says, what is the additive inverse of negative 9,276? Additive inverse of negative 9,276. Well, again, I'm using the number line, negative 9276. And the opposite would be positive 9276. I know you don't need the number line at this point. You can just, flip the sign. But that doesn't show me that you understand why. You need to, at this point, still show why. After this lesson, you don't have to. But right now, you're showing me that you learned the lesson. And this is how you prove it. Okay, so positive 9,276. Number 8. Evaluate 27 plus negative 27. So, I didn't write it down. 27 plus negative 27. So for this, we're going to start at positive 27. See how that's where we start? And to that, we're going to take away, or we're adding to it a negative direction of 27 steps. Imagine that you're standing on this number line right here, and you're going to walk backwards 27 steps. Okay, that's kind of what it's telling you here. And of course, you'll wind up at 0. Number 9. What is the additive inverse of negative 12? Okay, well, we're from negative 12, and the additive inverse is positive 12. And you don't have to write the positive because just putting the number by itself means it's positive. Number 10, 0 plus 9,276. Okay, if I'm at 0 and I add to 0, 9,276, I'm going to wind up at the number 9,276. It's pretty straightforward. If you have nothing and you add this to it, you have this. Another way of looking at it is you are standing at 0 on the number line, and then you walk forward 9,276 steps, all the way to get there. And I'm running a little bit out of room. I'm going to scooch this up. Number 11. A diver is 52 feet underwater. He rises up 25 feet. How much further does he need to rise to reach the surface of the water? So we can draw this out with water, and a diver is 52 feet, right? He's at negative 52. He's 52 feet under the water. He rises up 25 feet. So where is he at now? What is this level? Okay, how far under the water is this point? Okay, and then that in turn will be how much farther he has to rise up. We could also do this on a number line and say that he is at negative 52. We move 25 places. What is this number that he is now at? Okay, you can count it out, or you can do it like I saw some people, where you're going to take 52 and subtract 25. If you do this, I need to see that you are borrowing from the 5. This is called an algorithm. Similar to how this is a step-by-step process to solve for x, this is a step-by-step process for subtraction. It doesn't show you why it works. It just is a step-by-step process to get the right answer. This shows you why those numbers do what they do. This is just a step-by-step process for how to get the right answer. That's what we're going to do right now. So I'm going to borrow from the 5. It turns into a 4. And this is now 12 minus 5, which is 7. 4 minus 2 is 2. So this number right here is 27. I could have also said 52, 51, 50, 49, 48, 47, 46, 45, 44, blah, 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 all the way until I got to this negative 27 number, which means he's 27 feet under the ocean or has to rise 27 feet. Since this is a word problem, you are supposed to answer it with words. So he needs to rise another 27 feet. And that's your answer. Number 12, let's do this on the back. A plane is flying at an altitude of 35,000 feet. Okay, so an altitude of 35,000 feet, and we'll put the land down here, right? We've got some trees. Yay. Maybe there's a pond. Okay, the point is just to show that we're up in the air. Okay. It descends, that means it goes down 12,000 feet. then climbs 9,000. How far does it still need to go to land? I'm going to scooch this over so I have room to draw what's happening. So it starts at 35,000 feet. It descends, which means we go down 12,000, and then it has a new level. Well, then from that new level, it goes back up 9,000. So plus 9,000. It's still below where it was, which is 35,000. There are a couple ways that we can do this. I automatically see, because I have a lot of experience working with numbers, and the more that I've worked with numbers in this way, the better I've become at doing mental math. But I can see that 12 and 9 are really close. They're only 3,000 apart here, 12,000 and 9,000. I know 9, 10, 11, 12. Okay? So I could actually make these two numbers cancel out and say that this distance right here from 35,000 down to 9, or down to this point that we're at, because we don't know where we're at yet, is just 3,000 difference. And in my head, I can say that 35,000 minus 3,000 is 32,000. And I can do that in my head. I don't have to write it down. I just want to show you what I'm thinking in my head, which means that this level right here is 32,000. So the plane, let's see what it says. It says, how far does the plane need to descend to land? The plane needs to descend 32,000 feet to land. All right, if my mental math of kind of canceling out part of those was too complicated, we can do this in order. 35,000 minus 12,000. 5 minus 2 is 3, 3 minus 1 is 2, and then add back the 9,000 that it went back up. 9 plus 3, 9, 10, 11, 12. Put the 1 there, put a 2. 2 plus 1 is 3, and we get the same answer of 32,000. Now to upload this work, I would take my phone, take a picture of this side, flip it over, take a picture of that one, and just upload that. You don't even need to use the worksheet that is already there, or you could drop it into the worksheet, or you could just upload the picture. Either way.